Hello everyone, welcome back on another video on digital signal processor. In the last video, we have seen the interfacing of rotary encoder along with serial communication interface with C2000 microcontroller. In this video, we are going to interface in the LCD with C2000 microcontroller along with rotary encoder. So if you want to subscribe my channel, please go and subscribe the channel for the latest updates. So this is the launchpad which we are going to use in this project, and this launchpad is interfacing with the rotary encoder, and that we have done in the last video. So if you haven't seen the last video, how to interface the rotary encoder with C2000 microcontroller, you can check the link given in the description box. So the LCD which we are using, that is 16 cross 2 LCD, it is having 16 columns and 2 rows. So 2 rows and it is having 16 columns. And the LCD is having the several pins naming as the VSS, VDD, VNOT, and these pins are the ground pins, brightness control pins, and supply pins, reset, read-write pins, enable pins, and D0 to D7 are the data pins and anode indicator for the LED. So these pins we have to connect with the C2000 microcontroller, and the data pins, reset pins, reset, and enable pins are the GPIO pins. So here we are using the 4-bit data to transfer the data over the data bus of the LCD. So now we will go to Code Compose Studio and we will see how can we implement this with the C2000 microcontroller. So this is the project which we have created for the LED interface with the C2000 microcontroller. And if you want to learn how to create a project in CCS, you can check the video link given in the description box. So after creating the project and including all the necessary files for successful implementation of this project, we have written the header files and the source file for the LED interfacing along with rotary encoder interfacing. The first thing, we have to interface with the GPIO pins. We have to initialize the GPIO pins for the LCD. So how to initialize the GPIO pins for the LCD? So the GPIO pins which we are using, that is pin number 6, 7, 8, 9, 10, 11, 14 of the launchpad, and these pins descriptions are given on the right of every line. So these are the LCD pin configurations and LCD pin initialization. Now we have to initialize the LCD. So to initialize the LCD, we have written the functions, that is init LCD underscore initialization. So these are the commands that we have to send over the 4-bit data bus. And here you can see that we have to change the 28 to 38 if we are using 8 data lines. And if you are using 4 data lines, then you have to use the 28 instead of 38. So these are the LCD initializations for 16 cross 2 LCD. So now we have initialized the LCD, we have initialized the GPIO pins. Now we are writing the program for sending commands and sending the data to the LCD. So how to send the commands to the LCD? So we have to create a reset to 0. Once the set is done, we are storing the command, and that is unsigned character, and the command is stored in the temporary variables, and the temporary variables will be doing the AND operations with 0, 1, 2, 4, and 8, and the corresponding GPIO pins 9, 10, 11, 14 will be either that will be 1 and that will be 0, depending upon the combinations of these two variables. So once the GPIO 9, 10, 11, 14, that is a 4-bit data is transferred to the data lines, and that is the upper 4-bit. Now we have to send the lower 4-bit data over the 4-bit data lines. So these are for the command sending. Now we have to send the data. So to send the data, we have to use the set equals to 1, and the remaining thing will remain the same for the 4-bit data line. And here you can see that for the command, we have to keep the reset 0, and for the data, we have to keep the reset equals to 1. So we can able to send the command and data over the serial line, 4-bit data lines of the LCD. So there is another function for the LCD that at what line and what column we want to start our data to be displayed. So to do this one, we have to given the line number and the column number. And if line number is 1, we have to send the command that is 80, that is our operation with the column. And if your line number is 2, then it should be, we have to send the C0 along with the column number. So once this is done, we are sending the data using LCD data command. And there is another function whether we want to keep the cursor on, cursor off, and we want to clear the display. And once this is the basic initializations for the LCD interfacing, now we will come into the main files where we have included the rotary encoder _LCD.h files. This files we have added to the main project, that is rotary encoder _directory and LCD.c, and we have initialized the encoder page. How to initialize the encoder? If you want to learn, you can check the link given in the description box. So the encoder pins which are used the number 0 and 1. Now we will come into the main program. So in the main program, we have initialized the device initializations that initialize the device clock and the peripheral. Once we have initialized the device clock and peripherals, we have to initialize the device GPIO and disable online check. After that, we are initializing the encoder pin initializations and LCD pin configurations, that is also LCD pin initialization. And later we are initializing the LCD. So we are sending some set of commands to the LCD so that how you want to configure this LCD. So once this is done, now we are sending some commands to the line number 1 and line 2 on the LCD. That is LCD initialization done, LCD configured, then some set of commands to display that our LCD is working fine. So the encoder, now looking at the encoder, we have used the rotary encoder, and that is triggered with the help of external hardware interrupt. So external hardware interrupt, whenever the external hardware interrupt is coming, and then it will go to the encoder _ISR functions, and in encoder _ISR functions, when we are rotating in the encoder in the clockwise direction, encoder position is increasing, and we are displaying on the display the rotation in the clockwise direction, and the value also we are displaying what is the encoder position. So whenever the encoding rotation is in the anti-clockwise direction, the encoder position will be decrementing, and we are displaying on the LCD that is rotation is in the clockwise direction, and the value is the encoder position. Once this is done, we have to initialize the external hardware interrupt and that should be reached to the CPU. So that is done with the help of X crossbars. For the external hardware interrupt, for the GPIO pin 0 and 1, we are using the setup, that is GPIO underscore setup external hardware interrupt 1 GPIO 0, and for the pin number 1, we are using the pin 1. External hardware interrupt controller is the 1 that will enable the interrupts, and the polarity will be positive edge of the figure. So whenever the pin number 0 and the pin number 1 will be going on the rising edge, the external hardware interrupt will trigger, and it will go to encoder underscore ISR and do the necessary functions. And the for the interrupt, it is related to pi I1.4, and that will be equal to 1. So now what we will do, we will just run this program, we will just build this program. So the build is finished, there is no error in the project. Now we will debug rotary encoder 2 project. Now this project has been built successfully. Now you can see that we are having the launchpad, and we are having the rotary encoder and the LCD display. So now what we will do, we will run this project using this button, and you can see that LCD initialization done, LCD configured. This project demonstrates the encoder and LCD interface using C2000 microcontroller, that is Launchpad. Now please rotate encoder. Now we have to rotate the encoder, that everything has been done. So now what we will do, we will rotate the encoder, and you can see that encoder rotation is in clockwise directions. We are rotating the encoder in the clockwise directions, and you can see the rotations will be in the clockwise directions. Now we will rotating it is in the anti-clockwise directions. So this is the way you can implement any kind of applications using C2000 microcontroller. And if you want me to make such kind of the video, and if you want me to teach you, you can contact me, and don't forget to like, share and subscribe the channel for the latest update. Thank you.